Hello, we are now going to be starting, question 6 through 10 of algebra and functions. So let's start where we left off from last time, and yes. Let f of x is equal to ax squared and g of x is equal to bx to the 4 for any value of x. If a and b are positive constants, for how many values of x is f of x is equal to g of x? Well, first, because I see this, they ask for f of x is equal to g of x, I'm going to set this and this equal to each other. So f of x is equal to g of x. And f of x is just ax squared, so we have ax squared is equal to bx to the 4th. No, my mouse, it's dying. That's not good. Bx to the 4th. So, for how many values of x? So because we're looking for values of x, I'm going to try to simplify x onto one side. Try to make this work. So, yeah. So let's divide by x squared. So a is equal to b x squared. Then divide by b. X squared is equal to a over b. Then square root both sides. Indeed. Very beautiful. And that's going to make a plus or minus, right? Yeah, plus or minus a over b. The reason why this is plus or minus is because this was originally x squared. So let's say it's x squared is equal to some value, like let's say it's 9. X could either be negative 3 or 3. Because when you square a negative value, it'll become positive. So that's essentially what we're doing here. X squared is equal to a over b. So we're going to need a negative or positive. So we're going to have plus or minus a over b. So that gives us automatically two values of x. But we also have to be careful that there's also another value. So I'm looking at this ax squared from here. Just ax squared is equal to bx to the 4th. Basically, when you do some of these questions, you also want to look at some special cases. The ones I always look at is a negative number, so I choose negative 1, 0, or 1. I'm seeing as I already got some positive or negative value, I want to check 0. If it's x is to the 4th is 0, x squared is 0, whatever is multiplied by anything by 0 is 0, and 0 is equal to 0. So that gives another solution of just 0. So that gives us 3 solutions. So, yeah, our answer is D. So question 7. Let a and b be numbers. Let a and b be, yes. Let a and b be numbers such that 30 is less than a less than 40 and 50 less than b less than 70, which of the following represents all possible values of a minus b. Okay. That's muy interesante. So we've got the range is from 30 to 40. The second range is 50 to 70. This is b and this is a. Which of the following represents all possible values of a minus b. So when they're asking for all possible values, we're trying to look for a range. When we look at a range, we're trying to go from the most minimum values to the most maximum values, right? So yes, very much, yes. Okay, wait, just let me think. Okay, so 30 to 40 and 50 to 70. We're trying to find its min and its maximum, and then it'll be between that range. So what is the smallest value of a minus b that we can get? So the smallest value of a minus b that we can achieve is by taking the smallest number from a and subtracting it from the biggest number that b could possibly be. So 30 minus 70 equal negative 40. These are not minus signs. They're just showing that it's a range from 30 to 40 and 50 to 70. Not inclusive of 50 and 70 and 30 and 40. So negative 40 is our smallest number that we could possibly achieve. Now, what is the greatest number that we can achieve? Well, the greatest number we can achieve logically is if we choose the biggest number for a and the smallest number for b. So the biggest number for a is going to be 40. The biggest number that b is 50. So 40 minus 50. And these are non-inclusive, so I'm not putting less than or equal to. It can't. The b can't actually be 50, 70, and a can't actually be 30 and 40. I'm just trying to find what what range it could get. So yes, it's gonna be, oh, it could only be 31 and 39, or 51 and 69. But because they already give us this less than symbol, we could just go with 30, 40, 50, 70. So then yes, smallest number 40, biggest number 70, 40 minus, no wait, oh I'm sorry, 40 and then minus 50, negative 10. So a minus b. Is that an answer choice? Indeed it is. Let's go with b. 7 is b. Question 8. Is it here? No, it's not there. It's here. Okay. In the equation shown above, x, y, and z are positive integers. All the following could be a possible value of y except yeah, it's pretty interesting. So with these questions, trying to look for a pattern, I guess. And what you could basically do is see if you could get a possible value. See if you could get, and see, I'm looking at this, and basically what they're trying to do is basically that this one value that is not possible for y, what's going to happen is that either x or z will not be a positive integer or a positive whole number. So we could just go run it down through the multiple with the choices. So let's do y equals to 4, x over 3 plus 12. Let's run it with 4. Yes, we put 4. We know that 4/12 is just 1/3. You get a positive whole number here just by putting, like, let's say x equals to 2/3. So 2/3 plus 1/3 is equal to 1. So we're just trying to verify which ones do not work. Which one works? 6. Let's try 6. 6/12 is a half. So yes, okay, I see what they want. Okay. So is there any possible way that we can have a whole number here added to the 1/2 to make another whole number here? So the only other way to make this part whole is if this fraction becomes a mixed fraction or a regular fraction that it is equal to 1/2 or contains a 1/2. Like 5 and 1/2 plus 1/2 is going to equal 6, right? So we need a 1/2 here. But I don't know if you know, but not very possible. It's just not possible because you can never get x over 3 to equal 1/2 without x becoming a whole number integer, right? In the other example, we saw that when we had this was 4. We saw that x could equal 2/3, and then you would get a whole number on the other side. So we could see that once you put 6 and 1/2, you can't make x over 3 equal to a half or a number of mixed fraction containing 1/2 in order to get z to be a whole number and x to become a whole number. So if we run it with 8, let's just go through all the choices, because why not? Let's have some fun. 8 over 12 is 2/3, so I can already see we can make x 1/3. But let's make it different so that x and z do not become, sorry. We can make x over thirds like 4/3. That's gonna make it, that didn't do it for me. Oh, no, it did do it for me. 4/3 plus 2/3 is equal to 6/3. Get x equal 4, y equals 2, z equals 2, y equals to 8. So 8 works. If you just run it down with 12 and 20, you'll get the same thing. But I'm seeing that already we got b to be the evil child. Yes, so 8 is going to be b. Question 9. In the equation above, m and n are integers such that m is greater than n, which of the following is the value of m? So basically, what I'm saying here, we're adding to the same radicals together. So what is a common what square can we get into here that we could square root out? So one that's obvious is just 36. So square root of 36 is going to be 6. So we could take that out of the square root. 6 radical 2 plus 6 radical 2 equals 12 radical 2. So the answer is going to be B. That was pretty easy. That was pretty nice. That was a nice and easy one. Question 10. The table above shows some values for the function n. If n of t is equals to k times 2 to the negative at for positive constants k and a, what is the value of a? So already that we could see from both the table and the formula that they gave us, we're having a decay function because we have a negative exponent. And once you have a negative exponent, you're gonna start to have your graph's gonna look like this. You're gonna start having a graph that looks like this because whenever you exponent it to a negative number, what you would do is, let's say it's x to the negative n. It's really just 1 over x to the n. So you're gonna have this fraction that's exponentially increasing over here. And so as a result, you're gonna get this exponential decay, and you can see it from here, 128, 16, 2. It's getting smaller, but not at a constant rate. It's going smaller at an exponential rate. So that's interesting. So what can I start with? So k times 2. So we know that k is basically irrelevant. K is just going to be the initial y value. In this case, it's 128. So actually, for fun, let's have that there. With these exponential decaying growth functions, you're going to have this a1, I guess, a0. We'll start at a0. And that is basically the times some factor. How should we do this? We'll do the function in terms of t. The exponential growth and decay functions, you're going to have a starting number followed by some kind of growth or decay factor. And then this could be plus or minus, depending on it. If it's plus, your graph's going to look this. If it's minus, your graph's going to look like this. And then with another factor here, their time. I don't know why this was. No, we could just call this, what do you want to call this? We call this C, and we could call this D, I guess. These are both, C and D, I guess you could consider them both as like factors of how much you're decaying or how much you're growing. For example, let's say C was a higher number. You're going to be either growing or decaying faster. You're either going to be growing or decaying faster. If D was a higher number, then you would be you'd be growing faster. Or if D was smaller, you would be growing slower or decaying slower. Yes, right? So we have K is equal to, or in this case, A0 is going to be equal to 128. C is going to be our 2. D is going to be our A, right? So we have to get this A. So right from here, we need to look at the pattern from here. 128 to 16 to 2. I can already see a pattern. Each time you go through 1, every time you go plus 1 for t, you divide by 8. So that means by every increment that t goes up, you're going to have to divide by 8. Essentially, let's do this. 2 to the negative at. We know that every time you increment t, you're multiplying by 1/8. So let's say at 1, you're multiplying 1/8. And at 2, you're multiplying by 1/8 times 1/8, because you're dividing by 1/8 more, right? So like 128 divided by 8 is 16. To get to 2, it's divide by 8, then divide by 8 again. So essentially you're dividing by 8 each time, but if you look in the point of view of just 128, you're dividing by 8 once, then you're dividing by 8 twice, right? So with that, we could see that this 1/8, this multiplying factor 1/8 is it's multiplying it by itself over and over again for each time t happens, right? So basically, what we're gonna say is that what value of a can we get here, so that by each t, we're going to multiply by that factor again and again. So for like when t is equal to 1, we're multiplying by a factor of 1/8. When t is equal to 2, 1/8 times 1/8. 3, 1/8 times, oh no, let me take that out. It's going to be 3 1/8. 3 1/8? Does that make sense? 1/8 times 1/8 times 1/8. Right? So that means 2 to the negative a, and then we could write this, I want to rewrite this as 1 over 2 to the a. When you have a negative, what you could do is you make it positive, but you bring it down to the numerator. 1 to the 2at. Actually, another exponent rule. When you multiply, when you see exponents being multiplied together, you could also just take one of the exponents out. It's going to be like that. Yeah. So now that converts to 1 over 2a and then t. So we have to see this pattern. When you go for the first one, right, you're just having 1/8. For the second one, you're going to have 1/8 times 1/8. So whatever it's in here has to equal to this. 1 over 2a is equal to 1/8. That means a has to equal to 3. We'll go over it again. When a is equal to 3, it'll be 1/8 to the t. When it's 1, t equal to 1, you're just having 1/8. When t is equal to 2, you're having 1/8 times 1/8, or 1 over 64. 1 over 64 times 128 is 2. And if we continue this pattern, 1/8 times 1/8 times 1/8, which is going to be 1 over, that's a lot of math. Actually, let me do this with my calculator. I'm not smart enough. No, my battery's low. 64. 1 over 512 times 128, which is not going to be a pretty number, or I think it's going to be 0.25, right? So you're exponenting this factor over and over again. So the value of a is going to be 3. So 10 is going to be E. So that concludes everything for today. So yeah, that was pretty good, guys. Girls. It's pretty good, guys and girls. So yeah. Bye. Have a good day.